We will be talking about a few broad topics today. One is how data plays a key role in organizations. The esteemed panelists would be sharing some of their stories of how data plays a role in their respective fields and what should be the right organization structure, because remember, data science is still a very nascent field. Interestingly, the word data science itself is coined in the early 2000s, like 2002, etc., where it started becoming a practice a little away from the traditional statistics. So given it's a fairly new field and it's a fairly new team in a lot of organizations, it would be worthwhile to kind of pick our panelists' brain on what is the right organization structure. We'll also talk about a very interesting and a sensitive topic on data governance, and then we talk about possibly the careers as well as the pandemic and quickly the reactions of different organizations to it. For example, right, we'll just take a little bit step back and see that from where we evolved. Data was a support function in a lot of organizations, right? So there is a bunch of hypotheses, and then you're given this hypothesis, you go yes or no, you prove or disprove some of the things. So one of the famous British economists said that if you torture the data long enough or well enough, right, it will confess to anything that you want. And believe me or not, like this was a fundamental practice in a lot of organizations those days, that decision was taken through intuition and data was just backing it. But from that perspective, I think we have come a long way in a very short time. Today we run experiments at scale. There are models that gets trained on the go. There are things like multi-arm bandits and contextual bandits, where, for example, in Netflix, right, some of the banners that you see, the design of the banner itself is a key data input. So it depends on what you want to see in the banner to click and watch the movie. The banners get customized and personalized based on the user behavior, right? So personalization has taken the world by storm, and for example, that in search and recommendations are key to successes of a lot of businesses, right? If the user comes in and searches something and then you don't present the right result to the user, chances are that you're going to miss as an organization that sale. And hence data and what you do with the data has become a key differentiator in a lot of the organization. Certainly a big differentiator in digitally first organizations, but then there are also other organizations which were traditional, like manufacturing or banking, that is also getting on to this fast-paced micro decision making world of AI and data science, right? So that is that's kind of reality that would be a good learning, I think, for all of us. Maybe we start with this question. So why don't we start with Saurabh? Do you want to go first and tell us your experience of a particular use case that you think data played a critical role in it?
Sure. Thank you very much, Matangi, and welcome everyone. Just a logistics things would request people speaking to only keep the cameras on so that we see a lot of, like, we can see the panel together. Okay. So Matangi, very well questioned. We have tons of use cases coming in these days from all sectors. There are sectors which are very established and there are sectors which are emerging. I had the opportunity to work across my career, started a lot with financial services, working with American Express for a decade. Then I worked with in the Tata Group, setting up the analytics center, COE for there. And we had done all analytics from solve to software. Insurance was one of the big insurance financial services. We worked with manufacturing companies, retail companies, and the e-commerce company, which they launched that time. And then I moved into Motherson Sumi, which is an auto manufacturing company where a lot of IoT and analytics was the area. So I cannot imagine any sector today which cannot be touched with the use cases. Lately, I've been discussing a lot on the agriculture area. So you pick up an area which can be disrupted. If it has not been disrupted, it's a big opportunity. If it has already been disrupted, there are a lot of jobs there. So you could look at the glass from different angles. So I'll talk about especially manufacturing because we are covering different panels, or different panelists are covering different areas. So one of the things I'll talk about manufacturing. Okay. So the typical scenario of manufacturing, you might know that manufacturing is a capital intensive industry, and a lot of money goes in building the factories and stuff. And there is a component of value add in every manufacturing. So if people start from, say, maybe if you have to build, for example, you have to build roti, so you have to start with atta. Okay, somebody will start with grain and create atta. Somebody will start with atta, create a roti, and somebody will start from roti, create restaurant. So I was in the company called Motherson Sumi. So we were into a lot of creation of bumpers, dashboards, all the plastic stuff which goes into the car. And there are almost very big elements which are going. And the group was about 11 billion, is a group of 11 billion with about 250 factories. So we start with plastic, we create very sophisticated bumpers and stuff, and across all the value chain. Now, what you see is, you might have heard about this concept of GST or goods and services tax or VAT, and people think, so when you start with something and you finish, so you have to be taxed on the only value. So, but in manufacturing, what happens, a 100 rupees thing, 60 to 70% goes in buying something. So there is a lot of purchasing happening, and then you add value about 20-30%. And it depends on what manufacturing are doing. Some people start from 10 to 100, some people start from 30 to 100. So there is a huge amount of buying, purchasing which happens. So that's where the opportunity lies. When we were working in a company with about 100 to 200 units across the world, so the buying was almost to the tune of 4 to 5 billion, $5 to $6 billion across multiple factories. So here was a huge application of data to look at whom are we buying from, what are we buying, and how can we consolidate the buying and be more predictive in our buying patterns to optimize it. Because there is a huge amount of buying used to happen with the use of purchase analytics, one could optimize a lot. It's almost like the power of negotiation amplifies if you know really the depth of the details. This might not be, it's a very different use case. It might sound very simple, but trust me, having people talk to different organizations, and especially when the challenge comes in, when you have two different ERP systems and all. So bringing and many companies are built by acquisition. Somebody has an SAP ERP, somebody has an Oracle ERP, somebody has their own homegrown ERP. So building a data lake is the number one thing which you do. You bring in all the information. You look at your past purchasing patterns, you look at your future purchasing patterns, and then you look at what your buying needs, and then look at how you can negotiate better. So simple things from organizing data, from visualizing information, looking the forecast, matching the sales to it, helped us to unlock a lot of value. Yes, it's a little bit initial use case. The next use cases which comes are asset utilization, because you buy big machines. Each machine must be costing us about $1 million or so. So that's where the another thing. So asset utilization, you could think about if the machine runs only 5 hours in a day, then you are only utilizing that. But if it runs 24/7 by use of predictive maintenance and IoT, it unlocks next level value. So those are two use cases which I would leave you to think about. People talk a lot about IoT asset utilization, especially with the Ubers of the world. But spend analytics is a big opportunity. I see every retail and FMCG, any manufacturing should look at. Back to you, Matangi.
Thank you, Saurabh. That was not so well discussed about cases, generally. So I'll move to Dr. Chiranjeev Roy. So, Dr. Chiranjeev, would you like to, highlight some use cases that you have seen, in your career, and where you think data played a critical role? I'm sure there are plenty, but if you were to isolate one, what would it be?
So thanks to Saurav, you highlighted manufacturing. So I have spent most of my career in automotives, right? So I started with HSBC's risk management practice post my master's and so on and so forth. But then I developed some parts of it. I did my PhD in the same space, primarily in the automotive because General Motors and then Mercedes-Benz and Nissan Motors and so on and so forth. Now I had an organization which primarily focuses on media research, right? Media a lot. I'll talk about two use cases. I'll just take probably a minute on the automotive space. I'll get into a bit of more complexity now. We all know about something called crash tests, right? So what happens is you all have cars or vehicles or scooters and bikes, right? In order to understand the quality of a product, right, you need to actually stress test those products. Okay, in automotive, it's a very important thing, right? Because if it is not safe, you cannot use it. Now, the major problem is, do you know that the mechanical engineers who work on this space and all the vehicles that we all use, right, are manually simulated data, which is, I'm sure there are some mechanical engineers or engineering background people here, right? There is something called CAD and CAM, okay, computer aided designing and computer aided manufacturing, right? Those create simulations of body types who can actually go ahead and crash those vehicles and give a scoring or a rating. We developed a program which went on to, I cannot go into much of the details. Went on to developing patent. Imagine it is a humanly simulated thing, right? There is no real-time A/B testing, and one of the things that we all talk about is there is no A/B testing. But who will do an A/B testing on the grounds with this kind of a problem? So you can imagine the kind of complexity we are talking about. You cannot put a human being to go ahead and do a crash test, right? Because the human being will die, right? But you need to still test it. So you use dummies. One of the good ways is technology is increasing. So what we went ahead and do is we developed three-dimensional um, convolutional mixture models, basically, right? Which went ahead and create automated simulations, and the amount of data that we created was almost a million times, right? Almost of a million scale. So created human dummies and their reactions at a scale of at least 1 million, which took about almost 3 years of research, right? But this is where the scale and the productivity comes into picture. And then now it is getting into crash test safety and so on and so forth. You can look at Mercedes-Benz GLC class, right? You can see the crash tests, and there is a huge amount of improvement and leap, which would have not been probably possible if you don't use that kind of data. So this is where the extreme time that you cannot use human beings and data can be the only way that you can save it, right? So, but how to create data through deep learning is something that we all need to understand. So this is one problem. Media and entertainment. So media is exploring too much. We're not going to cinema halls, right? So you don't buy popcorns on a cinema hall right now. Okay. What do? We take next Netflix, Z5. We have multiple. These are called OTT platforms, basically, right? And these platforms, you just pay $4.99, right? And you go ahead and see it. But how do I understand whether you like some content or not? Does everybody like Mirzapur? No, I don't like so much of violence. I might like House of Cards. I might like something else, right? From that perspective. So, and we as viewers, other than the previous trial and tested methodologies, right, of understanding users' experience and user behavior, have been only secluded to Ministry of Broadcasting and some of the other people who are taking some A/B testing data. What is the new experiment that there is work that we are already doing, right? Which is only to a very small sample of the population. Is that how do you understand from Facebook, Instagram, and multiple other places, even those OTT platforms where you don't even subscribe, you don't look into them, and so on and so forth, right? You develop AWS pipeline of the information that you get as a textual response to start off with. We are also getting into video. We are also getting into speech. Right? So, for example, we all are talking to each other, right? We are all seeing each other. During this process, would I be able to evaluate whether you like it or not? Attention specific models. We are talking about generative adversarial models, right? How to run it on the fly. But this is all theory. There's some amount of work which is going into play, there is a lot of work which needs to be done. So development is important, but deployment is also very important, and that's what both these industries that I talked about is facing towards, basically. So this is my experience of the work that we have done so far, and what is next that we are looking at, a hyperscale user experience, because that's gonna rule the world from there. Yeah.
Thank you, Dr. Chiranjeev. Devapratim, would you like to highlight some of the use cases from your side?
Sure, Matangi. And a very, very interesting and exciting one from Dr. Chiranjeev and Saurabh. So now let me take you guys to a slightly different genre. We heard about manufacturing, automobile. I have spent 20 years in banking industry, so obviously I will talk about banking use cases. Now, the team that I have here is a pretty big one, and we are working on several exciting ones, strategic ones, and many of them are confidential. What I will highlight today, two of them, is where something has been publicly shared in the public domain. So one of the most exciting achievement of my team here has been recently when on 19 September, the president and CEO of Maybank launched AI-based offering to the market, totally developed in Bangalore by the team here, the data science team. So it's the first offering that was done by a Malaysian bank. Maybank is the largest bank in Malaysia. And it is the first player to launch this offering. So what is it? So as a bank, giving loans is bread and butter. Obviously, the bank earns money by giving loan. Now, one of the segment is SME segment. So what from at Maybank and as traditional bank, Maybank is a traditional bank like State Bank of India, Punjab National Bank. Now, as traditional bank, we see a huge shift toward fintech kind of offering. New AI-based players are coming into the market, and how a traditional bank then will survive or compete with them. So while the traditional banks have their own advantages, but if you are totally blind towards the fintech space, it doesn't serve your purpose. So in order for that, what we have launched is a real-time loan, artificial intelligence based loan for SME lending. So what happens when SME customers comes in for a loan? The time it takes to drink a cup of coffee, within that time, within 3 minutes, the amount of money, a multitude of decisions will be taken, all automated by artificial intelligence. So let's say one of you aspire to be a startup, you want to, you have just opened your shop, you need finance. So you just use the app or you log into the website. So at that time, by crunching the data that we have about you, it's humongous data that we have, internal data, external data, the entire AI system runs on a big data cluster. And after crunching the data, a series of decisions are taken. So when you are coming in, I need to immediately make a guess. I need to evaluate. Hey, are you my 20-year-old customer, or you are just startup who opened shop 3 months back, or are you a very established player in the market, or maybe you have some problem and or you have been good, but suddenly because of COVID you are facing some problem, cash flow problem. So trying to make a judgment about the type of the customers that has landed in my website. So that decision, then I have to finally make a credit decision. So a credit decision means actually giving you money. So in order to make that decision, a huge number of AI models simultaneously working and consulting each other comes into the play in the system. And then I have to, once I have made the decision that yes, I'm inclined to give the loan, then third decision, how much I have to give, whether I'm comfortable with a small amount or I'm open to give you a reasonably big amount. So all these decisions, which are usually taken in a traditional banking way by a huge number of experts or credit department, or risk department, Definitely, like any bank, Maybank has its elaborate processes, and people who are just starting up or even an established player will have to go through a pain. You have to come through a huge number of documents. You have to do several rounds to finally get the loan. But now it all can happen within 3 minutes. Even for some customers, we are able to give it in 1 minute. And we have seen the entire experience from logging into the system while these decisions are happening. It's a combination of on the fly and models running on big data clusters. So it's a real time, near real time. It's not instant. It takes about 3 minutes on the whole. So it's a really proud moment for the team here when it went live. I mean, we've been struggling for 2 years to get things correct, and we faced enormous challenges. As Dr. Chiranjeev was sharing in the beginning, that all you have to learn coding. So means it's not about model. So modeling is one part of the thing, a big part of the thing. But how you integrate the model with the IT system, how you integrate the IT system with the big data clusters, all three working together. And then you have this banking, huge banking regulations of KYC and whatnot. You'll go mad with this regulation. Everything together. We initially said we can do it in 15 minutes, 20 minutes. Our president says, no, you have to do it in 3 minutes. So finally, we succeeded, and we are live. And as I am speaking, it was launched in 19 September this year. And by December, the target was to disburse 500 million ringgit of loans. But even by end of November, we have crossed the machine. The machine created by our team here in Bangalore has already disbursed 500 million worth of loans. So that's something we're really proud about. So that's one exciting one. The other use case I would like to touch upon is in the area of optimization. So this is the earlier one, AI, which I was talked about, is machine learning, mathematics, statistics, data integration, all those parts. Optimization is more mathematical here in terms of the core subject area that we're talking about. But in terms of its business impact, this is a system. What it does is that as a bank, you have a huge portfolio, you have assets. How do you optimize your balance sheet? Are you confident that you would like to not increase your credit card exposure in Singapore, and maybe you want to reduce your home loan exposure in another country, in Malaysia? So what is the right way to manage the portfolio? Now, any bank does that. They have experts, they have seniors, they have processes. But now with today's world, when things move so fast, and I mean, if you're even late by a day or a week, you miss the opportunity. And even with slight, even I mean, experts usually ignore those things. Experts, you look at the big things. But there are areas when with slight tweaking in your portfolio, you can save billions of ringgit or dollars. So those are the areas where the AI come in. So it's not that we are throwing experts out. They're still there. It's a public sector bank. It's a government-linked bank. So we cannot throw anybody out. So here is a case where the experts and the AI are working in together. The experts are taking care of the traditional space where they add value. And the AI is looking in the area where experts are not looking, and areas where it adds values. So there are cases where we have saved in various portfolios of Maybank, the wholesale portfolio. The earlier case I was talked about was on the retail SME side, the retail or the small medium enterprise portfolio. This is for the wholesale portfolio. Again, huge billions of ringgit has been saved by recommendations or prescriptive analytics, as we say, that like a doctor prescribes. It prescribes that, hey, if you do this tweaking in your portfolio, nobody thought about it, but the AI detected that there is a potential. If you do it, you can save billions of dollars. So by keeping your risk same, not even a 1% increase in risk, you can improve your profitability and return. So that's the excuse case I'd like to touch upon today. And later, if you guys, any one of you have any questions, we'll be happy to take. So back to you, Martin.
Thank you, Devapathi. So we're going to talk about having seen all these use cases, be it manufacturing, automobile, or banking, right? as you have seen in all these solutions, there's something's coming together, right? The data is coming together, algorithms, people who implement it, the processes, like Devapratham said, the experts, all of them have to come together to make an AI solution truly. Like on the days where we talked about earlier, where data was only used for hypothesis testing and statistical analysis, it was pretty much dedicated to just one team, right? Maybe the data team, or maybe one more team, which is whoever is asking for the business team or product team or something like that. And it was possibly an Excel sheet report or a PowerPoint presentation, etc. But from there, we have moved ahead, as you have seen in all these use cases, to a point where we are driving billions of decisions, in few seconds, right? So these are microsecond decisions that systems are driving, and they can't just be built in an organization with just one team, right? So there has to be a structure around this. There has to be things that can make these AI solutions come live in organizations. So my second question, and what we're going to discuss on this, is what would be the right structure of organization that would work for large scale micro decision systems to take place, right? There have been two thought process here. The ones that I have been aware of and part of, there may be other such organization structures. I request the esteemed panel to kind of talk about if there's any other type of organization structure that would work. But broadly, I will classify them into two things. One is a centralized function where data is a centralized function, and everybody comes in, takes a request, or sends a request, or engages in a project mode or an initiative mode with the data science organization. Another is a decentralized one, where it is where data is embedded into different teams, different product teams or different business teams, and then they are able to work like as one pod, right? So there could be, for example, a credit card pod, or a or a logistics pod or something like that, depending on the business team and how the organization is organized. Now, both have their pros and cons. For example, centralization of getting all the resources under one roof and working on a project mode makes a lot of platformization and makes data platformization and sharing of projects and redundancies, get reduced pretty much, right? And then data scientists can share knowledge, etc., in that kind of a system. On the other hand, in an embedded model, what data scientists get is they get to see their value faster. It's easy. They're working very close with product and businesses to take their solution live. Becomes fairly easy and much more impactful from that perspective, because the data scientists get to see the value of their work day in and day out. On the challenges side, yeah, it will create the reverse of it. Like there will be redundancies across the organizations. There could be, some part of the same organization working in a different pod may bring in some expertise where the other pod organization may not be able to take it, right? So there is the, and especially pod organizations get tougher from a leadership role, managing your team, which is split across different pods, brings in their own challenges. So I would like to ask the panelists, what do they think of as the right organization structure for the data science to operate in the world of faster decisions? And what would your recommendations be? Maybe this time we start with Devapratham. So why don't you go first and tell us, what do you think of how should organization structure be for a data science team?
Yeah, sure. So that's a very good point that you brought up, Matangi, and the two threads that you have talked about, that one is a centralized way with a common platform way maybe, another is a product way, embedded way. So what I have seen within my organization, both, though I am inclined towards more the product way, but there are situations and cases where the centralized way makes more sense. And my view, and this is what I see within my organization also, that both the threads are equally used. So, for example, let's say that where we need the data for visualization purpose, where the final decisions will be taken by seniors or experts or a group of person by looking at the data in a concise manner and looking at the patterns and insight, getting insight from it, and maybe a little bit of predictive analysis as well. So in this kind of situation, we have seen that the centralized model really works well because the people or the users of those systems are a combination of data scientists and maybe business analysts or data analysts. And they don't have much time to work on the engineering side of the thing, to integrate, deploy, and all those things. They are probably business experts or subject matter experts or data scientists working in that particular genre. So in that situation, we have seen a common platform-based approach where a single platform can be used by several groups where they can interact with each other, collaborate with each other, look at the same information, and then take their respective decision. It works really well. And there, the organization structure is no separate. Each unit, let's say in the context of banks, since I'm from a bank, let's say there is a risk department, there is a treasury department, there is maybe a business unit department, credit unit department. So they can maintain their own organization structure, having their specialists, data analysts, data science reporting to their respective heads. So no new, they can just go with the standard existing organization structure. But now when you come to the product side, here the ballgame has totally changed. This is where, when you see the product embedded data science is where there is a huge departure, according to me, from traditional data science or traditional statistician's job that we know about. This is where what earlier Dr. Chiranjeev was also saying to you, that learn coding part, and Saurabh also echoing the same sentiment. So here, the organization structure that I will recommend, and I have also set it up for my own team, is a cross-functional team. The team should be like that of a Panch Pandava. So just imagine one Pandava. He's great, but alone he will not be able to have achieved the purpose. So here, for example, I can talk about the structure that I follow in my team. Is that I have 7 teams directly, and there are some other 2-3 teams which are indirectly concerned me. So for the 7 direct teams that I have, minimum they have 3 data scientists each within them. And then minimum I have 2 computer programmer or big data engineer in the team. And minimum I have 2 validators, model validators, who validates the model, validates the data, validates the integration of the model. And 4th, I have subject matter experts, domain experts, banking expert or risk expert. If I'm working on a treasury application, I have a treasury expert. If I have a risk application, I have a risk expert. So finally, these 4 kind of experts, plus when it's a product, when you interact with the users, we also have UI experts, UI specialists, who gives their knowledge on how the interaction with users should happen. So all these people on a daily basis works together. There is no hierarchy among them. They're equal. And the systems that we have, they have to compulsorily interact, collaborate within them. So these are the 4 and 5 genres that we have. And depending on the team size, so for some team, I have more data scientists. I have 7 data scientists in a team, 4 validators. But this is the minimum structure that we follow. So this is because alone, just having a statistician, alone just having a programmer would never solve the purpose. Only when they're working together to solve the problem, and here comes the IP, the knowledge industry concept. We are no longer in an assembly line where things are always same. We're in an agile way of working. Things change. You started the project today, again down the line 1 month, you know, oh God, things have changed and some new information is coming. So this is my suggestion, that in a product embedded way, it has to be a cross-functional, multidisciplinary team working together without any hierarchy. And in a centralized way, we take the advantage of the platform, the single unified platform gives us, but we maintain our own organization structure, which is suitable for that particular line of business of the unit. That's my person.
Sure. Dr. Chiranjeev, would you like to go next on this?
Sure, I think I'll echo what you said, Matangi, and as well as Devapratin. First of all, the problem needs to be very, very identified. That's extreme. Problem is the guidance for everything, right? So what are you solving? Is it going to have an impact? So that needs to be done by somebody at the top level, which requires for the first class of the engine which will come into picture. So it's like imagine like a train engine, right? So engine and then the bogies, right? So and so on and so forth. It has to work in a tandem fashion. And previously we have been agile. That's what Devapratim said, right? We are now in a different phase altogether. Now you just cannot write an algorithm that something is seen in a Jupyter notebook, right? I have developed 25 algorithms, out of which 7 algorithms are the best. And I'm sure we will all echo to the fact, and this is a very traditional practice, that the best algorithms of the world are not the most efficient algorithms that comes to a production scale. So everybody wants machine learning touch and feel. Please do understand that, even if it is big data or machine learning, right? How do you make that touch and feel? So what we do from that perspective is we have we initially engage with products and technology team. Post we know that these are the top 10 problems that we want to solve, out of which some of them can be solved by data, some of them cannot be solved by data. It's just a software product that needs to be made because it's not data ready itself, right? When we start developing the algorithms, of course, you need a domain expert in that field. For example, media and entertainment. I have a media and entertainment client. For example, anything that you want to take up, Netflix, right? So, what am I trying to solve there, right? You need an expert from that advisory field. Expertise comes from a time. Plus, you need the functional data science, mathematical, statistical objectives which can develop the algorithms. You need a Python API person who understands developing Python codes and then showcase it in an HTML, CSS, or creating Python APIs. Okay, that's extremely important because when when anyone needs to portray, right, as a big data scientist or a data scientist, right, whomever you want to approach, people will like to understand. Okay, you are talking about vector arrays and mathematics. This will come in that way. You'll have to run a cron tab and so on and so forth. This becomes extremely technical for the people who would want to understand what am I getting at the end of the day. That's extremely important. Once you do that, and the time frame that you normally get in the organization is not more than 6 to 8 weeks. Okay, that is beyond the time because we are all working on a fast-paced agile model. Fail fast, drive faster, right? In this 6 to 8 weeks, being continuously communicating, you proved that my hypothesis is either correct or wrong because you pick up the problem from there. Immediately, in during that process, you in the last 2 weeks, you have to figure out either you need PySpark, you need Python APIs, and so on and so forth. How do you productionalize? Okay, then you quickly bring in the broader team into perspective. So, what is the broader team? Devapratim and Matangi just mentioned, right? UX, user designer, because it's an user experience, right? You know, to develop an entire even if it is a service, right? There has to be an user experience which is coming into picture, right? What are screens that should come in? UI, HTML, CSS, right? So you convert the UX into UI and CSS interfaces. Then you get into how do you want to process the data ETL, the data architecture, and the data governance. And finally, how do you do the testing? Which kind of algorithms will go through? Because what you will feel when you take it to a production level, out of the 25 best algorithms that you have chosen for a problem to be solved, you will see that only 4 can scale up. For example, video processing is still not an area where big data is working. So you cannot run PySpark models over there. It's not possible. You need to parallelize GPUs, right? That is where you have to parallelize the threading, right? So you cannot run that model on the PySpark cluster. Text analytics can happen, right? Structured data analytics can happen. It can work in a stream flow. So you need to quickly take those decisions. And that is where your production level coding will come into picture. And everything that you need to do is to be done in that 12 to 16 weeks, which is a very, very small time frame. And you have to be very, very cognizant about how do you want to do. So you have a larger, broader team, which not only just works on algorithms, pick up the problem, prove the hypothesis, showing to the world, take a buy-in, right? And then scale it up at a very faster space because you already know that you have to, because once you do the data and data science architecture, it has to go into a software product for a software organization itself, right? There has to be balance between them. So data scientists and big data engineers cannot be secluded from the broader part of the world, which is software development lifecycle. We will not exist If we don't understand that, we have to be very, very techno-functional. Hence, I always say coding is very, very important. Do not forget coding, even if you worked in any field in data science, even for 20 years as well, right? Please spend your time diligently. There is a lot of advancements which has been happening, but still proving that your hypothesis works is very important. That's my thought process. Back to you,
Thank you.
Mataji.
Thank you. Yeah. So Sarab, would you want to? What is your recommendation of what's the right organization structure?
So I was just trying to write down what is left after you three spoke. So the best way I can do is just to summarize what all you spoke. But I'll try to bring in a different dimension. Okay. So if I state the question again, the question is what's the right type of organization structure which data science teams should be looking at? Okay. Now, to me, it's a question at the end. It's like how much sweet do you want the tea to be? And it depends on how much sugar you're ready to put in. And I had the privilege to work in an organization like American Express, where we had 1,000 people working in data science team. I had an opportunity to set up a analytics group for Tata Group and here. So at the end, the whole idea is what is the bigger mission you start with and where do you start the journey? Okay. So if it's a digital first company, let's take that example because that's not been touched about. So maybe say a GoGig or say any of the Flipkart or say any new startup which is starting today. So any digital first company will be analytics first. They will not think analytics 6 years down the line. So they will be part of the core team. In fact, the CIO would be more analytical than the technical, to be honest, because everyone is innovating by making a data product and building an app around it. Okay, whether it is a phone pay or a Google Pay or a Google Maps, analytics first products have been created. So those companies, it's the strategy. Analytics is the strategy. You cannot think without it. Okay. Then the second type of companies are companies who, the other extreme, let's go to the other extreme. Okay, companies which are traditional businesses who are saying, okay, now I am getting disrupted by analytics, so I try to experiment onto it. So they type of embed analytics slowly and steadily. Now for them, they might say, okay, I have an investment of 1 crore, 2 crore rupees, and I'll break it down into technology spend and the team spend. So anytime to start with analytics, it's always best to start with the COE mindset, because then you can have a Panch Pandav, at least 5 people join in, rather than, because if you have like 10 departments, you cannot have half of Saurabh, like you say, okay, half of Saurabh is here, and then somebody will say, okay, I will take the head part because that's the brain and you take the lower part. So that will not work, okay. So you have to have shared resources because you need a data scientist, you need a data management. In fact, you need more data management than data scientists in the beginning. Okay, you need business analysts, you need functional domains. So you need all of those 5 people, but you cannot share them. So you need to build a COE and you need to have the right structure. You have to have the think tanks, like people who have decades of experience doing it hundreds of times. So you start with a COE experience and then you build a culture of sharing. Now, basis your organization structure over a period of time, I see as the company becomes mature, I see it has to get embedded into the business. And it's a good situation that every team has a data scientist and it's like another skill. But the challenge I see, there is nobody like a full stack data scientist or a full stack analyst available. So you would need to have elements of all of them. I'm hoping data management, you don't need more because all products will be organizing their data automatically. So that function should go into the technology, and organization of data should be very clear, and visualization should be in products. So then the value extraction remains at the end and business analysts are there. So that's the epitome I see most mature companies going towards, whether that analytics gets embedded across and you have AI teams working on the like cutting edge or bleeding edge use cases. So that's the transition I see, but there is a lot of jobs which will be created in data first companies, analytics first companies, and a lot of jobs created in the companies which are survival. Companies who are not doing either of them may be disrupted. So that's my thought.
Sure, Saurabh. I think it's very valid. I also agree with the thought that organization structure also, boils down to the size and the pace at which organizations can run. So, of course, creating embedded teams requires a large organization and a lot of requirements from data science in every team. till that point, maybe centralization could be the way to go about. You're taking some threads.
Yeah, one point, Matangi. One of the things is as the organization scales up, the most important thing is delivering value every quarter. Okay, you should not be picking up the worst use case. Like I'll go to the moonshots on the first quarter. Okay, you have to start with small wins. Small wins could be simple that, okay, I tell you the state of your business live. Simple data visualization use cases are very good ones to get the numbers right. And these, to me, that will build the trust and it will get the money flowing into scaling up. Because it's like it's a video game. Okay, my son plays, like we have started playing Mario together. So it's like, you play the level 1.1, 1.2, 1.3, 2.1. So no company will say, okay, let's hire 100 people on data science or this thing. So value unlocking at each stage is a key thing, and that's a journey. There is no perfect thing, but at the end, leadership buy-in and value unlocking will help you get the right structure. There is no bad structure at the end.
Yeah, absolutely. I think and organizations these days are very fast evolving. So they are self-organizing maps in themselves. So they'll find the right structure that works for the organizations. So from taking a thread from what you said about full stack data scientists, right? So we a little bit touch upon the careers in data science also. I want to focus this topic to only data science. I'm not going to, or data science and analytics possibly. But the point is, as an entrant in data science and analyst, how should a data science person be, and what will their journey be like in the subsequent 5 or 10 years down the line? Some of my thoughts are on this subject that I would like to also point out is data science has data in it, right? So, and it starts from data. I've seen a lot of cases where data scientist starts from algorithms or starts from very classic machine learning thing, which is good if you know the data well. So it's very important to have understanding of data, understanding of algorithms, understanding, and most importantly, understanding of the business, and be very quick and smart in thinking, right? A combination of all these skill sets would create a good data scientist, right? And that is very important. And as you grow, what also differentiates you from the rest of the data scientists, because at one point it's not only about skill. It is about how much you learn, how much you're able to work with people, how much empathetic are you towards the business and problem at hand, how much problem solving you do, etc. Right? So over the career of a data science at regular milestones, let's say 5 years or 10 years or 15 years, there is a mix that changes between hard skills to soft skills. Even if you are in, there are careers today where you can be an individual contributor even at 15 years, even with 15 years of experience. But there is a mix of how much of how much of empathy, how much of understanding to the business that you bring in as you grow up your career as well. Because at the beginning, you may not know much. All you're bringing onto the table is your hard skills, right? And hard skills and knowledge. But as you grow up, you're going to bring in a mix of application. You're going to bring in a mix of the different sensitivities of the business context, different sensitivities of data around you. So that's how a data scientist or a person in the analytics field over a period of time. That's what I think essentially changes. It doesn't mean that you will stop learning or you will stop coding or something like that. It is also that you're doing more than just learning algorithms, or more than just using the data, or more than just building models. So with that note, maybe we start this time with Devapratim and start from there. Like Devapratim, what do you think about this thought process?
Right, absolutely. So a career in data science, my advice to all of you is that it's not a shortcut thing. Meaning, I'm glad that all of you have invested time for this program in Goa Institute of Management, where you're putting in 2 years here. But there are people who thinks that, oh, I will do a 2-month thing, 3-month thing somewhere, either online or maybe something, and I will just somehow get a data science certification and that's it. Then there is a thought that, oh, it's very easy, just download a few libraries and just put in some command, just write LM and that's your regression is done. That's it. So it's so easy. So a lot of people and a lot of learning people talk about the data science like that. And that's a perception, but it's in a certain section only. So don't fall in that trap. That is my advice. Like a doctor, it takes 5 years to get the MBBS degree. And during that time, he or she learns so many things. After that, also the journey continues. And it's only after 10, 12 years, probably the doctor is known in the market, he's actually doing a practice. So it's a long journey. Similarly, if somebody is a nuclear scientist working in a R&D organization, has a long career track, same as data science. So it's not a 2-month, 3-month certificate course. Now, why? So here, as we have been discussing in this total event, and everybody, Saurabh, Matangi, everybody is touching on the same thing, that you have to learn multiple things. So let me give you an example. Since I am from banking and finance background, I started my career by being a CFA, Chartered Financial Analyst. So in CFA, to clear the exam, like many of the exams, you have to clear 10 subjects. So if you are good in 5 or 6, you will not pass. That I will say I have got 80-90% in 6 of them. I just got some low marks while you are failing. No, you have to pass on all the subjects. So you have to be very good in finance. Of course, this is a finance degree, but you have to be equally good on statistics. They have a statistics paper, and just it's not joke. It's really serious. Then I was very proud of myself that I am first class first. I had economics, mathematics, and statistics as combination when I was in St. Xavier's College, and I got first class first. And I had this mental impression that I am very good in economics. And what happened when I was doing my study days in CFA, the economics paper, I didn't look at it. I said, oh, that too I know back of my hand and I will just pass like that. Oh my God, when I opened up, I said, what a mistake I did. It's so deep and whatever I have learned, it's nothing, it starts from there and it's very deep. So what I'm trying to say here, I'm trying to say there are 10 subjects. You have to go deep in all of them. It's not that you just scratch the surface from top and you learn, you do a Google and Wikipedia on those 10 things and talk about it a few lines. Not that. You have to really go deep. And that is what is needed in data science. You have to know big data systems. You have to know mathematics. You have to know statistics. You have to know programming, and that to multiple languages. And you have to know the domain also, whatever is your area. If it's manufacturing, it could be automobile, it could be banking. So just imagine so many things. So it is doesn't going to happen in 2-3 months. It is a year-long journey, like a doctor. So all of you have made a good start with your program here, where you are getting an overview and reasonable depth in various areas. Then I am sure you have labs where you should be practicing and all. And once you start your journey with the organization, you will get hands-on experience, and then you go on from there. And maybe you do further studies, you keep on adding your qualification. So again, I summarize that don't think it's a short thing. You write a LM command and that's data science. It's a long journey. You have to go deep in various components, have patience. And if you feel that you don't have the patience and you didn't think or you're not prepared for this long journey, then maybe you should look for something else. Then, like, for example, I am not good for doctoral field. So I am not prepared for a 15-year journey in biology and all. So you have to know whether it's the right thing for you. You have the passion for it. Then the career opportunity is unlimited. So organization in the earth can bypass this. And even you need not join an organization. Start something on your own. The opportunities are immense. Whether you start something on your own or in an organization, career growth opportunities are unlimited, subject to you invest in this time on this multiple area, develop this competency over time. So that's my suggestion. That's it.
Dr. Chiranjeev, would you like to chime in on this question?
Sure. I think Devapratim summarized it very well, and you also, Matangi. After my 18 years of working, as in, I still call myself a student, and as like all of you, all my panelists here, I felt that I don't know seriously something, right? So For 18 hours, I was into continuous back-to-back meetings, which I never really wanted. I was losing the passion on coding, right? So first of all, I come from, like Rebooting, I come from statistics and mathematics background. Okay. No clue about what to do. I landed up in London. I need to pass a SAS exam, right? With a guy who is 65-year-old, who is a director, who's got two PhDs in statistics, as in one PhD and one postdoctorate, and one PhD in mathematics, right? You sit with that guy and pass the credit risk examination. Okay, did that for 5 years, right? After that, suddenly in one of the discussions, I thought that let's go to America, right? I landed up in America, and suddenly there was a discussion with General Motors organization, and I don't have any clue about it. Just that in my statistics, I learned something called quality control. I said that you're putting an amazing system. That time Industry 2.0 was hot. We will bring in some great robotic arms which will do some great amount of activities, right? I said, do your engineers know how to do this? Have we created the process for them? How will you manage it if it breaks down? I was just a kid, right, in the block. That shocked the director to the general manager, and general manager in an automotive company is very big stuff, right? Who have handled it. So at this point in time, so he handles about 2,000 people, right? So more than that. So how can an adverse boy of 4 years experience can ask this kind of question? It's a very big thing in those days itself. Now we have a lot of transparency from that perspective. So what is more important? These are some of the examples where you will never learn a domain. You'll constantly learn yourself. But I would start from minus, basically. That is where we all are, right? As in, you have gone into Goa Institute of Management, maybe probably just after your bachelor's, right? Or maybe you have spent some time in your industry, right? So I would start the graph from minus to go to zero and then go up, right? It's actually a sine curve. It is not linear. The process is not linear anymore. Okay. You cannot create a line curve right now. It is very sine wave. When you start from the other quadrant, one you should be technically very much acquainted that this field requires your hands-on working, right? You cannot be an architect to start off with. You will have an architect. Somebody will be an architect who understands what to solve, to be precise, right? But having been on the minus level, you should have the basics in command. So, and that's where the key thing is. You need to understand the technologies behind it. You have been using that in the space. One of the questions that I always get, right, even when I teach PGPX and stuff like that, is that I just got 4 days of training for big data out of my 4 semesters. How will I do it? But did anybody in the college stop you from taking up something that you can do? And that's what Devipratim said, right? During this minus phase that I call it, right? -1 to 0, right? This phase. Why don't you build things on your own, right? Sit down and so on and develop stuff from that perspective. There is immense amount of data around you. Nobody's stopping you to create a practice and develop that perspective, right? Because that is where makes you perfect. You will be able to know whether you want to develop a Python API or a PySpark API, right? Whether it will be running or not, whether which kind of algorithm will fit in into practice, right? And then when you get onto the discussion table and you have proven your mind that I understand your problem, I developed an process and I have solved it as an output, right? Every manager understands this in a very simple language: input, process, and output. You need to understand the inputs, process the output, process the data, and produce an output which is relevant to the person which is required. And that's what every key hiring manager does from that perspective. We're talking about getting into scale. You land up in the job. Now starts your zero. One of the questions that I get when people work, right, is I was in a call with one of my Japanese clients in the morning. We all typically know how Japanese are. They keep quiet till the time they need to keep quiet. I was in a 5 o'clock in the morning. The only problem, he said, Dr. Roy, you know what? He never writes down the problems. And that fellow is a PhD, right? That fellow is a PhD, right? So he's been working in US and in Germany and so on and so forth. The only challenge that was faced is he didn't write the problem. So nobody has a photo memory, right? He didn't write the problem, and then when he came out after 3 weeks with an output, with a brilliant class of some amount of code, he did some research and so on and so forth. So for 2 weeks he never communicated, right? When he came to the discussion, right, it was thought that the problem which was understood was not even the problem that needs to be solved. That is the key thing. Of course, I'm not telling you that in the first 2 years, 2 to 3 years, you will become a domain expert where you will understand the problem. But it is a habit that needs to be cultivated among you. If you can cultivate this habit, automatically your domain grows. Probably some of us who are sitting here are millennials, probably, right? I am millennials, right? So 2001, I started with 2000 and born in 1980, right? Um, it it is precise to the fact that we didn't have access to computers and so many other things, right? And we don't have digital notebooks and so on, and digital pens and so on and so forth. I still stick on to my notebook and pen. While Devapratim was asking me, talking, I was writing the points. That's how data scientists should be primarily. If you don't write down, you don't evolve, basically. So -1 to 0 and 0 to wherever that you want to scale up. Everything is dependent upon how lean you are, how much do you practice technology, practice science, practice the way of solving the problem. And that is the only way to succeed in this field. Otherwise, you can only land up in sales or strategy. That is my point. Thank you. Back to you.
Yeah. Thanks, Dr. Siranjit. Saurabh, would you like to go on this question?
Nothing, you are not nice to me. So I'm left with again nothing, but it's okay. So I'll reflect on few things. Okay, the question was how to look at career in data scientist in the data science area. So to me, I would say, data science is not one role. It's a area, like it's like a ecosystem of opportunities. Okay, it's not one role you get into. And as we were saying, Pandav, there are almost 7, 8 roles which come in today. And each, when I started my career, like Dev Pratim said, he started as a CFA, right?
Yeah.
And Chiranjeev started as a statistician. I started as a tech guy, okay, and I ended up like I also started in 2000. I'm kind of not the millennial born, but the millennial worker with the Y2K thing happening. I wanted to, like, I went through I joined MBT, Mahindra British Telecom, with a 6 month intensive training, paid training. People used to give us salary that time. It was great. Today you pay for trainings. So, and I topped, unfortunately, in COBOL. Okay, and they put me in a mainframe project. Think about that time when everybody used to carry a Java and I hated, and I quit my company. Okay, almost like with that hatred that I've been put in, and then I landed up somewhere and in electronic data systems, which was heavy in airline software. And then Y2K happened. Some plane hit the things, and all e-commerce, whatever was the buzzword had gone, and I ended up learning Unix. And that was the best thing which happened for me. And then I got into data warehousing that time. And then data warehousing led into data visualization, into marketing campaigns, then into risk management platform, then into like whatever. So what I'm saying is you will be presented an opportunity to start with somewhere. Okay. Now, and you can create your own roadmap. Okay. Not on day one, you will be the full stack data scientist who knows everything. And to be honest, glad Chiranjeev, you mentioned SAS. I was also born like SAS and Unix first. Like I started with scripting something on SQL, then SAS, then R came in, now Python has come in. So at the end, don't be a Python data scientist. Okay, be a data scientist or be someone who knows algorithms, who knows logic, because that will stay. There'll be 10 more tools which will come in tomorrow. Okay, I have seen 3 waves at least, and I'm sure there'll be 10 more waves coming in. And more waves will come because these softwares have become free. SAS lived a long time because it was the only paid software and there was nothing called open source. As soon as R came in, then it changed. Now Python has come with libraries. So because it's free, then anything can be evolved. So the learning mindset becomes more important now. We can binge watch Netflix over the weekend for 20 hours, but we cannot take a course. The course is the opportunity thing that I can only do between 9 and 7 during office hours when company will pay me. But to be honest, the best and the most cutting edge work is not available in books and in courses and in colleges. The best work is available on Google in talks and into companies like do free projects. If you want to really learn the things, volunteer for projects. And in fact, the best area to volunteer is not in corporates, to be honest. It's in startups and in government projects, because government projects are working on the most cutting edge fundamental problems, which are poverty, food, weather, COVID. Okay, nobody, like very few organizations are working on this. So to learn, if you're really passionate about learning, like the first thing is you have to have a learning mindset. The challenge when you come out of college is, in college you have to pass exams, you have to get good numbers. I also did the same thing. I also passed the minimum amount of numbers and I got 70%. So you are forced to pass an exam. But when you're in corporate, nobody forces you to learn anything. It's an infinite competition. You have 300 rupees course and you have 3 lakh rupees course. Your aim is to get a certificate, your aim is to get learning. That is the call you have to take. And that's the most toughest decision. It's easy to get into the bed, like in Delhi, it's winter, so I love it. So slowly I said, okay, I'll first sit and learn. Then I'll say, okay, let me just lie down and learn. And let me put on my cap and then I learn. And then suddenly I'm dozed off. So it gives you nice sleep, but the learning mindset is a big thing. The other problem I see is, the grass is greener on the other side. This is the problem which I see, when you once you get the entry into it, like somebody gets an entry as a business analyst, but what happens is the data engineer wants to become a data visualization. Why? Because it's a little bit higher paying. The data visualization wants to become a data scientist. The data scientist wants to become an AI engineer. Somebody says, no, consulting is more glorified. So that Me Too mindset is a big disaster, to be honest. Whatever you get opportunity, you do your best, because if you don't do your best, nobody will provide you another opportunity. That's a problem. And there are enough jobs for everything. People who are like, if your data, like nobody stops you from learning Python. Now, if you have been put into data engineering and you can only work on SQL, nobody stops you from learning Python. And your leader will be happy that you experiment in 20% of the time. But there is a myth that 20% of the time is in your office time, 20% of your time is in your personal time, which is like Saturdays and Sundays. Okay, so if you do your best out there, people will be happy to consider. But to get another job, what I've seen, what works best for me, because I switched, is I offered free help to people. I said, okay, I've thought through your problem statement. This is your problem statement. This is how you will solve. And you can Google up everything. You can copy paste from different industries and give them the solution. People will love to that you have to start with an hypothesis, because consumer behavior is a consumer behavior. You know consumer behavior, what it is. So for example, I'm in e-commerce. Be a consumer yourself and see, if you're a data scientist or a data engineer, what's the journey you're trying to see. And then map it back to the data and see where you see the same thing. Because first, knowing how the data speaks the consumer journey, you need to know how the data is coming out. So one simple thing, which if in case of e-commerce and web analytics using Google Marketing Cloud or Adobe Omniture is, okay, if I log in, what are the data points come in, and you start looking at patterns and you start interpreting it. And then you go back and see what are the patterns. One small example from my career I can share with you is a very simple journey of called forgot user ID and password. It's a very big point, because people come in, they are not able to log in, and the buy journey does not complete. And what used to happen is we used to get a lot of calls, almost 1 million calls for this forgot user ID and password. And people used to go to the website, try it out, fail, and then use the phone number and call. And we used to be frustrated that, why are we getting so many calls? And then we looked at the data, we tried to say, okay, we did side by side with the customer and figured out the problems, went back into. So I'm just taking, consumer, you have to play the role of a consumer first and then map it to the data, and slowly you have to build your intelligence and then use that intelligence or patterns from the data into this. Because unless you do the first, you will not understand how the data is making the journey. And these are micro segments which will come in. Okay, there will be hundreds of micro segments which will show you this thing. They are not macro trends which will come out, because you are making 1% improvement across. So consumer experience is what you go like a UX testing. Okay, you go log in.
Yeah. So
imagine if you don't like a artist, right? You will create their memes and put it onto the blogs, right? That is a behavior, right? You don't want to type a sentence in Facebook or Twitter. You just create their meme. You don't like somebody in Mirzapur, you put it up there, right? And you will throw all the kind of. This is a behavior, right? You don't know how to track it, right? So the dimensions of giving information is also changing. Hence, the way the data scientist needs to think is also changing. Yeah, and they were altogether.
So another to the question about the consumer behavior, let me give you an example. Where do you sleep and when you sleep, we can tell a lot of things about you. For example, to the topic, I mean, the rebooting with data and the question that you asked about consumer behavior. For example, I know that when you sleep, your phone is in the same location for at least 6, 7, or 8 hours or 9 hours, depending on how much you sleep. So just by studying when your phone remains in the same location for 8 or 9 hours, I know where your home is. And now that I know your home, I know whether from your home you have public transportation available to go. Suppose you want to go to the airport to your institute. I know that whether you have public transportation or you have to rely on Uber or Ola to go to the airport. And I can accordingly give you a recommendation, an offer. For example, then another example is that suppose when you go to a restaurant with your friends or relatives to dine out, I have noticed, I'll just give an example. Suppose I see a pattern that you always come back by watching a movie after the late night movie after the restaurant. So if I have to give you an offer, a credit card or some wallet, I better give a movie offer coupled with a restaurant offer. Or maybe also in the restaurant, I see a pattern that usually you go Italian or Chinese. These two types are the most you go. So this is how data, machine learning, data science, and the question you asked about consumer behavior are all linked together, and you can create a lot of things out of it.
Yes, sir. Thank you, sir. Thank you, sir, for this wonderful answer. So as we have some time constraints, so I will ask the last question. I will ask Saurabh Srivastav to ask his question. Sorry, Shubham Srivastav to ask his question. Shubham, are you there?
Yeah. Thanks, Om. So my question would be, like, due to pandemic, everyone has been talking about industries getting affected, but no one talks about how COVID-19 has impacted the data analytics domain in our country. So anyone would of you like to share on this aspect? Like, how is the general point of view regarding data analytics getting affected due to COVID-19 in our country?
So if I can chime in here quickly with, I see this in two parts. One is data kind of showing patterns, which, for example, the company could invest in. We do see some of the, like, for example, e-commerce is one thing that has benefited heavily during the lockdown. We don't need a pandemic for the industry to get benefited, but that's a benefit that has come through e-commerce. A lot of adoption has happened that in the e-commerce sector. And then online grocery is another one area that a lot of companies got into during the pandemic, because that is an opportunity that came across because people were inside the house and they wanted grocery. People did not want to order food delivered to the home. Again, there is also some growth towards health, and healthy foods and things like that. Again, online doctor consultation is another industry that has kind of seen and witnessed a lot of growth in. So data in one way has helped us see some of these patterns. And at least in Gojek, we did look at the COVID pandemic separately before and after, looked at some of the consumer behavior changes during this period, identified new businesses. New businesses got launched during this period because transport, which was a big part of Gojek, did take a significant fall during the lockdown period. So there were teams set up, etc., to identify what is the pattern where our consumer behavior is happening, and to identify new areas of investment for the companies, right? So that's one thing. The second thing that at least I feel good about is, and this is my personal opinion is on the work from home angle. Data science and analytics is largely can be managed from home. Of course, different people have different preferences. So from work from office to work from home, we are now talking about work from anywhere, where people who have choices to go to organization, to go to physical spaces, can go, and people who stay at home and want to work and work. And I'm assuming such a trend will also get more diversity and women participation in the workforce. So this is in my nutshell the positive impact of COVID.
Yeah. So let me add something on this from my side. So, the good part about COVID has been that companies are becoming efficient, like we are becoming healthy to build resilience and build stamina. The companies are also trying to look to cut down the fat and be more nimble in this. So I've seen many companies, like the company which I was part of, the number of projects of data science we had were immense. Okay. And the speed of adoption was very high. A lot of times we used to wait for approvals for weeks and weeks and review meetings, because everyone was so focused merely on the business impact, making organizations work in a very analytical way. So the adoption became very fast, and the first teams which are getting investments are analytics across all sectors. I'm not sure very few companies might be downsizing because of the business, but that is a big area. A lot of jobs are getting created, and in fact, almost they're saying about more than 5 lakh jobs in the analytics sector are expected to be there in the next 1 year. So it's a big opportunity area. Analytics has huge application. Okay, we spoke everywhere. The top sector of analytics consumption today is financial services, followed by retail. And then the e-commerce, online companies, and then the last two sectors which are now coming up are manufacturing and agriculture, which I would say definitely opportunities are there in established ones. The opportunities there are new ones, but I cannot think of any sector which will not be disrupted by it. And people are looking at it as an efficiency thing. Like everyone wears a Fitbit to become healthy, it is a must-have now. So every company would have an analytics department. Every company which has an analytics department will be scaling up, but definitely they will be optimizing it, because analytics tools are also becoming very efficient. So you don't need large platforms team to manage Hadoop cluster. You could do it just by using AWS. Out of 5 people, only 1 person can do it. So the disguised unemployment in analytics teams will also get addressed, to be honest. So just keep on learning, as we said. Opportunities are immense. Even if you are a business analyst and you don't want to, he will make you do it. So
thank you, sir. With this, to conclude this session, thank you so much, Mathangi ma'am, Chiranjeev sir, Debapratim sir, and Saurabh sir for enlightening this session and sharing your experience and use cases presented during the discussion. I am sure that we have learned something new and have some major takeaways from all of you. The discussion, in a way, walked us through the changes that have occurred in the industry and how the dynamics are changing with respect to getting back to normal. Samriddhi, in association with Team Parigyan, would like to thank you again for taking out your precious time from your busy schedules and gracing us with your presence. We hope to seek your guidance in future.
Absolutely.
Thank you so
Best
much.
of luck to all of you. Keep learning. Thank you.
Thank you so much.
Amazing session.
Thank you, sir. Thank you, ma'am.
Thank you so much,
Have a
sir.
good weekend.
Thank you, sir. Thank you, ma'am, for an
Thank you so
insightful
much.
Thank you so
Thank you
much,
so
sir.
much.
Thank you, ma'am.